Math time!
Not every sequence has a convergent subsequence, but the Bolzano-Weierstrass theorem tells us that every bounded sequence does have a convergent subsequence. This is Math 504 Advanced Calculus. This time, we are asked to prove the Bolzano-Weierstrass theorem. Now, what is that Bolzano-Weierstrass theorem states all about? So, the Bolzano-Weierstrass theorem states that every bounded sequence has a convergent subsequence. Alright, so here we go. We have Bernard Bolzano, the one who promulgated this kind of theorem, together with Mr. Carl Weierstrass. Let us remember that in the Bolzano-Weierstrass theorem, we are trying to prove that we've got a convergent subsequence. This theorem will guarantee us a monotone subsequence. Then if we can prove it's bounded, the monotone convergence theorem will guarantee us that the subsequence converges, and then we'll be done. That is why we have to take a look with a review about the monotone subsequence theorem. Here we go. So it states that every sequence has a monotone subsequence. Now moving on, the monotone convergence theorem, let A sub n be a monotone sequence, then A sub n converges if and only if it is bounded. So let us now begin with an arbitrary bounded sequence. So here's the proof. Let A sub n be a bounded sequence. Say A and K is a monotone subsequence. Well, of course. Is A and K bounded? Well, of course it is. So we can write then A and K is bounded. Well, if we're going to take a look, that every term of a subsequence is coming from the original sequence, and our original sequence is bounded. So all of the terms of A sub n are bounded. The terms of A sub n include the terms of its subsequence A and K. So A and K is definitely bounded. Then we can apply the monotone convergent theorem. Remember that when we say monotone convergence theorem, let A sub n be a monotone sequence, then A sub n converges if and only if it is bounded. Okay? So that's why we can then, by MCT, we can then A and K converges. Alright, so if we would like to have, or if we wanted to state this theorem as a conditional statement, if a sequence is bounded, then it has a convergent sequence. For the converse, if a sequence has a convergent subsequence, then it is bounded. Do you agree with that one with the converse? Well, the converse is not true. As you would probably guess, since the theorem wasn't stated as an if and only if theorem, then can you think of any or unbounded sequence that has a convergent subsequence? That's why let's have this for example. Here we go for the example. So we have here x sub n is the sequence with a value of 0 for odd n and a value of n for even n. Clearly, the odd terms make a convergent subsequence of 0, and the even terms will just diverge to infinity. So having a convergent subsequence does not guarantee that a sequence is bounded. But by the Bolzano-Weierstrass theorem, which we just proved a while back, that's saying if a sequence is bounded, then it has a convergent subsequence. So going back to our previous proof, we have here the summary. So let A sub n be a bounded sequence, say A sub nk is a monotone subsequence, then we could say A and K is bounded, as we could write A and K is bounded by MCT, that A and K converges. Let us just all remember that the Bolzano-Weierstrass theorem states that every bounded sequence has a convergent subsequence. So, alright, that's all for today. This is Math 504 Advanced Calculus. Thank you for listening. God bless.